Can you hear me? Okay, good evening, everybody. I'm really excited to be here, but I have to admit that I feel like much more comfortable when I'm there. Okay, so first of all, I would like to thank both Simon and George, who are organizing these talks every month, and it's really a great job. So thank you so much for this. Today, so my name is Didier Boelens. And today I'm talking about, the reactive programming, and especially the notion of blocks. The way I see it, the way I understand it, the way I used it, and so it's purely me. So let's start. So, if you think of a way of writing an application where parts or components of the application would know very little about the others, maybe do not care at all about the others, where they would fetch some data from a bag, and their duty is to deliver some other data to another bag, or maybe the same bag, without even knowing where precisely these bags are. And even better, if they don't know what will happen to the data they deliver to the bags. Will it be used directly, now, later, not used at all? They don't care. And also, they do not know anything about the data they fetch from the bag. So, also, the components could be moved around or interchanged with no or very little impact on the code. Also, if you think of an application which mainly responds to events, this is my personal understanding of reactive programming. So, reactive programming, in very simple words, is programming with asynchronous data streams. Or another word is only do something, react upon when an event is triggered. So first, it might be necessary to make a little refresh on the notion of streams. Very briefly, I won't go into the details because there is too much to say about the streams, which is wonderful. But here, just the basics. So what is a stream? A stream is nothing else but a sequence of events which are ordered in time. So in other words, think of a pipe with two ends. The pipe is controlled by what we are calling a stream controller. Once it is instantiated, it exposes a first end, which is called a sink. The sink is the end where you are going to inject things into the pipe. So, sorry for this. When the data is in the pipe, there is another end, even with no data, which is called a stream. This is where you are going to listen to the content of the pipe, of the stream. But as long as there is no listener or there is no active listener connected to the stream, nothing goes out. Everything remains into the pipe. Once you activate a listener, when you subscribe to a stream, it starts flowing or emitting events. There are several ways of doing it, either via, let's say, a subscription, or indirectly, let's say, via a stream builder, which is a wonderful component. We'll talk about it a bit later. What could be injected into a stream? Anything. Be it a variable, be it an object, a collection, a map, a stream, a future, anything, which is very good, but also errors. So there exist two main types of streams. The first type is a single subscription, who's accepting only one listener during the whole life cycle of the stream. And the second type is a broadcast. A broadcast allows any number of listeners, which is a very big advantage. And each time that you are adding a listener to a broadcast stream, it starts receiving the events as of the moment it started listening to the stream. Now here comes, let's say, one of my favorite widgets in Flutter, the stream builder. The stream builder is a widget that listens to a stream. Finally, it subscribes to a stream. You may put a initial data inside the stream, and each time that an event is emitted by the stream, it calls a callback, which is a builder, providing, let's say, the data that goes out the stream. Then you simply have to react upon, let's say, the data, and if there is data, you build a widget based on the data you receive. If there is no data, you do whatever you need to do. This has a very big advantage. The very big advantage is that only this, let's say, widget is rebuilt when an event goes out, is emitted by a stream. It's wonderful, this widget. So now, let's go to the main part of this presentation, the notion of BLoC. Once again, I repeat, this is my interpretation of the blocks. So what is a BLoC? A BLoC is an acronym which stands for Business Logic Component. So what is this? This is a kind of placeholder when you are running some kind of business logic. A BLoC is theoretically defined as only be accessible through streams for input and output. And normally a business logic component, a BLoC, should remain totally independent from the platform, the environment, or even other components. This is what the theory says. So what is the main idea? The main idea is you have a BLoC which exposes sinks and streams. Other components or widgets are interacting, let's say, with the BLoC via the interface. What's inside the BLoC and what the BLoC does, it's none of their business. They don't need to know about it. They simply need to know, okay, in order to access the BLoC and to inject something into the BLoC, I use these things, and I'm listening to output streams. That's all. What are the advantages of this? First, and maybe most important, is the decoupling. Oh, yeah? You can update or replace the content of a BLoC or even a BLoC without any impact on your code. Of course, there is a restriction or a constraint that you keep the interface the same. Testability, another point of importance as well. You can test the BLoC thoroughly without depending on, let's say, the user interface. You can test the business logic from A to Z without any trouble. Or you can even mock, let's say, the BLoC. The third one I see is reusability. It's much easier to reuse, let's say, a BLoC because it is totally independent in one or different applications. First personal note. Theory says, okay, a BLoC is only accessible through sinks and streams. Yeah, no problem at all. Personally, I do also consider that nothing really prevents from also using getters and setters and methods. as long as, okay, you keep it clean, I would say. Also, sometimes you could use, let's say, the BLoC as some repository for data you want to exchange across the application. But this is not the theory, what the theory says. So now let's talk about an example of a complex flow that you already saw many times, I suppose. The famous user authentication flow, where when you start an application, the first thing that the application does is to check if the user might already been authenticated in a way or another via Facebook, Google, whatsoever. If the user is not yet authenticated, it needs to redirect the user to the authentication screen, from which the user might decide, if it is not already registered, to go to the registering, let's say, screen. Once the user is authenticated or newly registered, we need to redirect the user to the home screen. Once the user is authenticated, okay, from anywhere in the application, it might be necessary to put a button that logs the user out. And when the user is logged out, he should be redirected to the authentication screen. So this is a common, let's say, behavior. If you need to write this kind of code, it might be very complex. Not difficult, but complex. Using the BLoCs, it might become very simple to write. First, you define a BLoC whose main responsibility is to handle all the things related to the authentication. Then you have a decision, let's say what I do call, let's say, a decision widget, which only listens to a stream, which is exposed by the BLoC, which tells about, let's say, the authentication status. Based on this, the decision might decide to redirect the user to the authentication screen. Then the user decides to go to the registration screen or whatsoever. But then both screens only interact with the authentication BLoC to send requests, be it log me in or register me. The authentication BLoC is the only one who negotiates with the server for the authentication. The outcome of the negotiation might be returned to the registration or the authentication screen, for example, errors, authentication failures, whatsoever. But also, if the outcome is successful, the authentication status will change. Then the decision will be notified by the authentication BLoC, who will make the decision to automatically redirect the user to the home screen. Then the application goes on, and from any other part of the application, you put, let's say, a widget which is responsible for logging out the user. This widget also interacts with the authentication BLoC to log the user out. Then the decision is notified by the stream and automatically redirect the user to the authentication panel or screen. So it is very easy to do. You have only one BLoC, which exposes, for the sake of clarity here, 3 things: login, register, and log out. The authentication screen, I would say, only knows about the login and only cares about the login. Registration, register, and the logout, the logout. Then we have a decision widget who is listening to the authentication status stream and will take the decision upon the events that will be emitted. And the authentication and registration, let's say the same widgets or screens there, will also listen to the authentication action status to be notified about, let's say, the results of their request. And then you see it's totally decoupled. And there is very few if, then, else, or branching, etc. So how to instantiate a BLoC? This is also something important. So the rule is a BLoC must be available or accessible. And either in an ancestor, which is the rule. So an ancestor is a widget which is higher in the tree hierarchy. And if you need to put the block somewhere in an ancestor, you will use a provider, whatever the provider might be. I'll come back on this later. Or nothing prevents you from directly instantiating as well, say, the block. We'll talk about it a bit later as well. So, the block provider. The block provider main responsibility is to inject the block somewhere in the tree hierarchy so that it will become accessible, available to the widgets which are part of the tree. So the block provider, okay, mainly relies on the use of inherited widget. Now the implementation is not very important. Use, let's say, the one from Remy, which is very generic. Use others. It's not really the most important. The one from Remy is really good, by the way. So in order to retrieve the block, simply call the block provider, telling, okay, which type of block you need to retrieve. And if it is higher in the hierarchy, you will have it. As simple as this. So, but where should we position a block? This is a big question. So, first case, if you want a block to be accessible to several pages, screens, or what we are calling routes in Flutter terms, there is no other way. Either you put it on top of the material app, I will explain, or you could also use a BLoC singleton. Why on top of the material app? Simply because internally, let's say the Flutter screens or routes are part of a stack. So this means that their context, they never know about the others. They are not sharing anything in common. So the only way of sharing something in common is to put it a bit above. But nothing prevents you from using a singleton. Okay, I know most people hate this, but why not? Another case is where you want the block to be accessible to a tree of widgets. So then the same rule, it must be above. Then if you want both these two widgets to get access to the block needs to be on top of these widgets. Exactly the same here. This way, both and the screen, the widgets and the widgets B will be able to access the block. Of course, you need providers to inject those blocks. Third case, if you only need a block to be available in one particular instance of a widget, then you don't need to have it above. Maybe you can, let's say, directly instantiate it inside the widget itself. This is what I personally call, let's say, part of. It's very useful, for example, if you have, let's say, shopping basket items, if you have, let's say, selected items, etc. So let's go to practical examples. Of course, I could have, let's say, used, let's say, most of the samples you see on the internet, which are form validation, which are authentication, which are what else? Yeah, HTTP requests to a server to grab, let's say, page lists of results. But I wanted to show you that you can do much more with the blocks. The blocks could be used for any kind of needs. And for this presentation, I created, let's say, two practical examples. The first one is a pattern locker widget. Okay, so it's very straightforward. The user needs, let's say, to draw with a finger a certain pattern on a keyboard. But I want, of course, all the widgets part of the pattern lock, let's say, widget, to be totally unaware of each other and to be totally unaware of the logic behind the scene. So how to do it? So you have, let's say, the different cells. I'll be calling cells. You have on top of this a layer which is responsible for only one thing, is to draw the pattern. So the architecture is, let's say, I've got the material up, I've got a screen, and I've got, let's say, the pattern widget. The pattern widget instantiates a pattern block, and then I have a stack of cells which only know one thing, their identity. Are they 1, 2, 3, 4, 5, 6, 7, 8, whatsoever. And we have the pattern drawer. I have to admit that I was on a train this afternoon and I realized that I could have do much better than what I'm going to tell you. Okay? But keep it as it is. It is really, it could be improved very much. But the principle is, I choose, is to have the one pattern block which exposes an add cell, sync, and which flows out, let's say, the list of all the selected cells within a pattern. I have another block which is simply responsible for accepting the list of all the cells which are part of the pattern and tell the corresponding cell whether the cell is part or not of the pattern. So the cell, okay, only knows about its cell number. The cell block tells when that particular cell is part of the pattern, and when the cell is part of the pattern, it changes, let's say, its colors. Then we have the pattern drawer, which is only responsible for listening to the list of all the cells which have been selected and to draw the corresponding pattern. And then the pattern widget responsible for handling the gesture. I could have done, let's say, better in having the cell telling itself to, let's say, the pattern widget, hey, it's me that I'm hovered by the finger. But I will do the changes and will provide you the sample later. So what is the flow? We have the pattern widget. We have the gestures, which are, let's say, caught by the pattern widget. The pattern widget identifies which cell is hovered, then adds it, sends it to the pattern block, and the pattern block does a decision. Do I accept the cell? Do I reject it? Based on a business logic, which is not known by the widget itself. Let's take the example that the cell is accepted. It is added to an internal list of cells, which is which is sent to the stream, which is exposed by the pattern block. Then the cell listens to the selected cell and directly send it, let's say broadcast it, let's say, to the cell block, who will tell the cell either it is or not selected. At the same time, the draw pattern is also listening to the list of selected cells to draw. There is no tight coupling between the different components, and it works. So I'm going to show you. So here it's a square 4x4, and simply, okay, I click and drag, and I have, let's say, the pattern that draws. everything works together without knowing anything about each other, but it just works. Another example here now. A second example is something that normally shouldn't work with the streams. For a clear region is tempo. But I wanted to show you that it's really doable with the streams. So what I want to achieve is a bit broader. I have a screen which is made up of, on top of it, let's say, a series of bars. Each bar corresponds to one note, one musical note. When the note is played, the bar is full. Then there is an animation that starts and lowers the bar as long as there is no same note which is played. I have 3 tracks. Each track is, corresponds, let's say, to a music track. But do not know anything about it, about the music itself. It just receives a note, and if the note is to be played by this track, it launches an animation that will make a note fly from right to left. That's it. Then the animation, the note itself, when they will be shifting from right to left, will simply, let's say, inform about its identity as note, but also as regards, say, its position in a track, in the animation. Because I want to put an additional business logic, I only want to play, let's say, the note when it arrives at 40% of the track. This is a decision I made. Then I've got, let's say, 3 buttons, each of these being responsible for turning the sound of a specific track on and off. And then the buttons, let's say, to control, play, reset, or, let's say, don't do the music. Of course, once again, I want all these components to work together independently of each other without knowing anything about each other. So how to do it? I could have, let's say, selected only one block, but for clarity, I wanted to have 2 blocks here to show you that you can, say, split the responsibility. A first block is responsible for reading, let's say, the music score and to streaming the notes, and also responsible for the tempo. Another block, which is a player note, the note player block, which only accepts a note and its position within the animation. Will take the decision whether to play it or not. And if it plays the note, okay, to stream, to emit an event that I'm playing a note. That's it. Then I have, let's say, a widget, which is a bar note, who knows only one thing about which type of note is supposed to listen. But is not listening itself, is relying on another block, who is simply responsible to tell the bar note, okay, hey guy, you are part of one to play the animation because the note is yours. Of course, when it plays a note, it resets an animation controller and, let's say, to play the animation. Then we have the track. Same principle. The track only knows about this track number, 0, 1, 2, 3, 4, whatsoever. And the track note tells the track when a note is played, whether it is for this particular track or not. Simply because the track needs to know to play an animation, to launch an animation, and because we need to launch an animation based on the position on the track, of the track itself. I don't want the animation to be somewhere in the screen. Then the button track on off responsible for turning let's say the fact of playing the note on and off based on a track. This is it. So how to do the architecture? So we have two providers, okay, to inject the two blocks. I have the page here, which only, let's say, instantiate a series of bar notes. Here I have, let's say, the 7 bar notes. And telling the bar note, okay, you correspond to the note A, then you to the B, and so forth. Track, the same, okay? I'm instancing each track and telling the track, okay, you are number 1, number 0, number 2. And same for the buttons. Then the track players, when we will start to play, will emit the notes that will be listened to by all tracks. Track will take the decision, thanks to the track block, to launch an animation. The animation will be launched, and in the course of the animation, it will tell the note player, okay, hey, I'm the note A, and I'm in a position 1/3, 1/4, 1/5, let's say, of the full animation. Do whatever you want with it. The note player will run its own business logic and will take the decision either to play the note or not. If it plays the note, it simply emits an event, okay, I'm playing a note. This is the note I'm playing, which is listened by, let's say, the bar notes, and the bar note will play or not, let's say, the animation related to the note. Same for the track. The track, when you will be hitting one of the button to turn the sound on, off, corresponding to a track, they will tell the note player, okay, I'm track number 0, for example, and I want to turn it off. Do whatever you want with this piece of information. And the note player will tell everyone, let's say, okay, either they are on or off. Okay, simple as that. So, of course, normally, in real life, you would have had, let's say, something not written with streams. But simply to let you know that it's very feasible, here it is. And once again, the sound is off. Okay, I promise the sound works normally. Murphy's law. It did work.
Batterie à 100%. Connecté à Didier Boelens.
Doesn't want. Okay, too bad. So, anyways, so as you see, a note is playing, is moving from right to left. Then the corresponding note bar, let's say, reacts upon, let's say, the note which is played. If I hit, but here it won't be, let's say, noticeable because the sound doesn't work. Okay, but normally you shouldn't hear anything about, let's say, the corresponding track that you turn off. Too bad. So Murphy's law. Voilà, that's all I wanted to tell you about, let's say, the blocks. There is so much else to be said, but 40 minutes, it's not that much. So my name, as I said, is Didier Boelens. You can find me, let's say, on the internet under Bouledy. GitHub, okay, the GitHub, Twitter, but I'm reading Twitter, but not tweeting a lot. On Medium, okay, there are, I don't know, four articles, but sorry for this. I forgot to push new ones. I've got my personal blog, both in French and English. I released, let's say, packages, and maybe this package, okay, the sound pool package, I will release it as well. My personal email and phone number for the ones who might be interested in. So thank you very much for listening to this.
Does anybody have any questions for Didier? All right, I'll start at the front and move my way back.
Hi. I have a question. How do you facilitate communication between the blocks? If you have one block event happening in one, actually will affect something in the other. Do you go through the whole flow, or there is some communication going directly between the blocks? And I've seen that you position one on top of another, what it actually have to go up and tell something.
Okay, thank you for this question. So the theory says that normally you should never provide a block with a reference of another block, simply because you want to keep the total decoupling between the two. Now, if a block, the output of a block is the input of another block, how to deal with it? It's maybe because your architecture is maybe not decoupled enough. If you have practical cases.
Yeah, so very simple case is that I have a basket, but to have this basket I authenticate it, and I'm building this basket, and suddenly my authentication server on one of the requests says your token is not valid anymore. I should get you away, wipe your basket, and change everything. So how do I react to this?
What you could do maybe is to have a state event, let's say, type of control, where from a state or from an event, okay, you emit a state which is caught by one or the other in order to do some business logic behind. But give me some time to think about it. I will come back to you. No problem.
I was going to ask about streams in Dart and RX and how different they are. Because I played around with streams a little bit in Dart, very small amount, but I noticed there are quite a lot of big differences between the standard terms that are used. Are there any underlying differences?
Okay, so here I didn't want to go into, let's say, a deep explanation about the streams because it's a very huge topic. Personally, I'm almost never using only the Dart streams, let's say, async package alone. I'm using the very beautiful, let's say, RX Dart package written by Brian, which offers, let's say, all the richness of, let's say, the ReactiveX streams, okay, offering you observables, subject, and this is what I use the most. Mainly, they say the publish subject and the behavior subject. This is something that would, let's say, deserve a full presentation, how to correctly work with the streams. It's much richer than most people think.
Cool.
It is.
Quick follow-up. Is stream controller more like a publish subject or a behavior subject?
This one is a publish subject. Because the difference between a publish and a behavior is that the behavior, when you are listening to, subscribing, let's say, to a behavior subject, okay, the very last event that was emitted by this behavior will also be caught by the listener. And it's very useful.
Thank you for your talk. I'm following your posts a lot, and I've been using them to build my application. So thank you very much for your insights and for your lessons. I'm coming. My question is more from the memory management point of view. I'm coming from a .NET background, and memory management is really a hot topic there. And I know that you need to dispose your controllers, your stream controllers. After you dispose all of them, does the block get in garbage collected in a sense, or does it stay on a heap or on a stack in the application?
Okay. There is a wonderful article that was published or posted 2 or 3 weeks ago related to how the heap or how the garbage collector actually works in Dart. I don't recall, let's say, the link, so maybe we could post, let's say, the link, and it will explain you, let's say, that you don't have to worry. The only thing that you do need to worry is, okay, I'm coming from the C language, okay, and it's old now. Okay, but with C, you had to be very careful about the memory you are going to allocate and deallocate. And I do favor the fact that if you don't need to do something with something, okay, you simply dispose it. That's why for me, a BLoC provider or any kind of provider might be, let's say, implemented as a stateful, let's say, container, simply because to take profit of the dispose, override, let's say, method of this stateful. So that if, for any kind of reason, a stateful widget is being removed, automatically your blocks will also be removed. Of course, Remy, okay, in this provider, okay, externalizes the fact of instantiating, let's say, something or disposing something. Two schools, up to you to decide. Use the ones with you are the most comfortable. Okay, but it's important, let's say, to release a resource, that's for sure.
Any other questions, anybody?
How did you implement this node slider?
Pardon?
Node slider. How did you implement this?
The node slider.
Yeah, this white background, and now it's going from right to left on your final application.
How did I implement it?
Yeah.
Oh, it's straightforward. It's a simple container. Okay, I can show you the code if you want. I don't know if I have the time to show. Stop. You are useless. It's a pity because I spent so much time. But that's my thing. Okay, so which one are you interested in?
White background and nodes going on.
All right. So this is, let's say, the track node, the track widget. So it's very basic, yeah.
Can you make it bigger?
I try to. Like this. Okay, so in order to draw, let's say, the track, I'm using a layout builder. Okay, simply to differ and to obtain the constraints of the placeholder where to draw it. Then a container, okay, with some decoration, so borders. Then I have, let's say, a list view builder, which simply instantiate 5 containers with a simple, let's say, bottom level or top level, I don't remember. It's a bottom border in a certain color, and this draws the tracks. Okay, as simple as this. But the most interesting part of this build is the layout builder to obtain the position of this particular track on the screen, thanks to the use of a post-frame callback, which will, let's say, get the actual position of the track on the screen. As simple as this.
Okay, thanks.
Anybody else? Right. Well, I have a couple of announcements. One is around a hackathon, if you would like to pop up here. And also, I'd like to say thank you to Essential for sponsoring tonight. I'd like to add that they're also hiring. They're looking for Flutter developers, designers, and Elixir developers. So if anybody is interested in talking to me or Nick over there, like we can put you in touch and hopefully help you out. Okay, quickly.